Hey everyone, today we are going to learn about something called bias. So, basically, what's bias? In plain English, it's some sort of partiality or the natural way of humans showing difference. So, in context of machine learning, before that, let's learn this in the view of mathematics. So basically, what bias is, let's say you have a set of values like this and 2, 3, 2. What you'll do is you'll find the average of this, and let's say you want some sort of value like 10.2. So from the real value, you'll take away the expected value or the average, so that you'll end up with some sort of value, and that value can be either negative or positive. There are two kinds of bias, negative bias and positive bias. And what to choose in the context of machine learning? Let's say we are building a bridge, and if I overestimate the cost, that will be positive bias. So, in the case, I want the model to overestimate the budget or the capacity. Overestimate the capacity so that the bridge will be strong, because there will be other natural elements that may involve and that may break the bridge. So in this case, adding a positive bias is the best case. And coming to negative bias, let's say you're traveling to somewhere, some sort of point A to point B. If you underestimate the traveling time or the arrival time, there will be things like you either leave early or choose some sort of fast transport. So in these cases, negative bias makes sense. So basically, bias is something that occurs in nature, and that is inevitable. In the previous videos, we have learned about linear regression training, where I use the x with the weights. X are the values from feature matrix, and these are the weights. So to make this possible, we'll just add this bias so that the whole equation is balanced. And in today's NEET code problem, we are going to learn about a neuron, where a neuron is something that is represented like this. There is an initial layer, there is a final layer. In between, we do some passes, and sometimes we backpropagate. Most of the times we backpropagate to validate outputs, and after all this training, we arrive at a result with adjusted weights. So basically, that's the neuron, and it imitates the human brain. So let's solve the problem quickly, because in the next videos we are going to learn about back propagation, multi-layered propagation. They are quite important, and this is just the whole linear regression training pass, but with a bias. So let's call this Z, and what I have to do initially is to find this value. So that will be np dot. I need to find the dot product of the x and the weights, and after that, I'll add the bias. So this will be the z. So after computing the required value, we'll use an activation function. If you don't know what's an activation function, you can visit the previous videos about ReLU, Sigmoid, and softmax. So basically, ReLU keeps the value positive always, so that we don't run into different issues, and sigmoid keeps the values from 0 to 1. That will be like 1 plus e power, oh god knows, I think e power minus x. So we'll just keep the values between 0 to 1, so we'll end up with a binary value like yes or no. And here the problem has some sort of string that says sigmoid or relu, and if the activation is sigmoid, we'll apply the sigmoid function. That will be this 1 by 1 plus e power minus c. That will be exponential power minus c. If you don't know what e is the natural limit that exists. So let's call this result, and that will be 1 by 1 plus np dot xp to the minus of z. That will be our result. And if the activation is relu, I think we need to use 2 equals. If the activation is relu, we'll just keep the max of these two, 0 and z. So if there is no case, let's keep the result as z, and let's return the rounded value of the answer and up to 5 decimals. So basically for the first case this will work, but there are some sort of edge cases like zero point 0 where the value should be between zero point 0, so we can skip the decimal values. So this is the problem, and it is done. And this single neuron is also called perceptron. And for the next videos, a little heads up, the who are watching this video, they need to go through something called chain rule. that's that shows up in maths most of the times. So this is most important for the back propagation part, and bias is quite simple. So for now, this is about a single neuron, and this is how the pass is done. So let's revise it a little bit. Initially, we'll have some weights and some features. We'll multiply them and add some bias, and after that, we'll keep the values from 0 to 1, or 0 and greater than 1, so that we don't lose any connections, all that. In between we apply gradients so that we don't deviate from the real answer we need. So this is about the single neuron, and in the next few videos we are going to learn about other stuff related to back propagation and some maths involved in between. So thanks for watching. Please like, share and subscribe.